Hi everyone, I am Shubham Garg and welcome back to the lecture series of C++. So in today's lecture we are going to see how to calculate the roots of a quadratic equation in C++. Alright, so these are the formula of calculating the roots of a quadratic equation. Okay, so a quadratic equation is basically in the form of ax square, that is ax to the power 2 plus bx plus c. Alright, so this is the form of a quadratic equation and we need to find the value of x to solve the quadratic equations. Alright, so this is our standard form for quadratic equation. Now to find the value of x, we have this formula, that is x is equal to minus b plus minus root of b square minus 4ac divided by 2a. Alright, and here this b square minus 4ac under root is the determinant, okay, that is g. So we find d as root b square minus 4ac. Alright, then we find the value of x. Okay, so depending on the value of d, there are different cases. Alright, so there are some cases, that is, let's say, okay, let's just add the equation. Yeah, so let's say b square we have is less than 4ac. This is the case 1. The next case is b square next case is b square is equal to 4ac, and the third case is as you have already guessed it, b square greater than 4ac. Alright, so based on these three cases, there are different categories of the roots which we are going to find for the equation. So let me just show you the categories. Okay, so these are our roots, these are our cases. So if we take in consideration the first case, that is b square is less than 4ac. Alright, so in this case the roots are complex, that is, they are not real. Alright, similarly, if we take the case that is b square is equal to 4ac, then in this case the roots are real and equal. Okay, that is both the values of x, since it is a quadratic equation, so we will be getting two values of x, both values will be real and both values will be equal. Okay, so now the final case, in b square greater than 4ac, the roots are real and different. So these are the three cases. Okay, and while we are making the program, we are going to check for the case, and accordingly we will calculate the value of the roots. Okay, so basically the user is going to input the value of the coefficients, that is a, b and c. Okay, and based on that coefficient our program is going to calculate the value of x. Okay, so this is the logic which we are going to implement on our program. So let us start with the program. Okay, let me just remove the previous program. Alright, yeah. And let me just increase the size of text a bit. Okay, yeah. So this is our program, this is our main section. Now here we need to add some more header files, okay, because we are going to use some maths function. That is, we need to find the square root, we need to use a power and these kind of functions. For that we are going to use a header file, that is hash include, okay, math.h. Alright, and besides that we are going to use another header file, that is bit slash standard C++ dot h. Okay, so these are basically used for the formulas which we are going to enter, and we are going to use the mathematical operation. So that will be our program will be able to interpret that. So for that we need to include these header files. Okay, so let us start making the program. So we are going to create our function. So let's say I create a function that is void calc to calculate the roots. All right. So here I am going to write 3 arguments, that is integer a, integer b, and integer c. Okay. So these are basically the values of coefficients, all right, which we are going to have input from the user. So now let's say first of all we are going to give a condition, that is if a is equal to 0. All right, if you remember, we have a format that is ax square plus bx plus c. So if a becomes 0, then the equation becomes linear equation. So that case will become invalid. All right, so this will be C out, and we are going to print invalid because we are finding the root of quadratic equation. All right, then here we are going to return the value. Next we are going to define another integer, that is the value of d. All right, so we are going to define integer in d is equal to b square minus 4ac. All right, so now we are going to write d as b squared, that is b into b minus 4 into a into c. All right, so this is the value of our determinant. Now we need to take the square root of this determinant. Okay, if you remember, the equation was square root b square minus 4ac. All right, so now here we are going to define a double, and let's say we define it as square root d, which is equal to, we are going to use sqrt function. All right, so that sqrt function we are able to directly use because of the mat.h library which we included. All right, so here sqrt function, and now we are going to write the abs for absolute. Okay, because we do not need the root to be negative. All right, that will become a complex equation. So now we will take a square root and we will get the absolute value, that is positive value for d. All right, so now here we are going to check the cases. We are going to see if d is greater than 0 or less than 0, that is what kind of roots we are going to get. Okay, so let's say first case is if d is greater than 0. So here we are going to print that roots are real and different. All right, next thing what we are going to do is we are going to use the formula to print the value of the roots. All right, so here we are going to see out. Now we are going to write first of all double for the decimal values, and here we are going to put the formula, that is minus b. Now there are plus and minus, two values, that is minus b plus minus root d upon 2a. Okay, so here we are printing first the plus case, then we will print the minus case. So here we are going to write minus b plus we are going to write square root value of d. Okay, that is this variable square root d, because minus b plus minus root d upon 2a. Okay, and here we are going to divide it by 2 into a. Next thing, we are going to print the value for minus b minus square root d. Okay, so here again it will be double. So minus b minus sqrt underscore d divided by 2 into a. Okay, so this is for our first case when roots are real and different. All right, so for the second case, we are going to use else if let's say d is equal to 0, d equal to 0. So here roots are going to be same. So cout we are going to print roots are same. All right, and here what we are going to do is we are going to write since d is equal to 0. Okay, so d is equal to 0, so our equation becomes instead of minus b plus minus root d by 2a, it becomes minus b by 2a. Okay, so now here we have the minus sign, that is for minus b, and here we are having double b divided by 2a. All right. Now next thing which we are going to do is we are going to write our final condition, that is if d is less than 0. Okay, so in this case the roots are complex and imaginary. All right, so basically the roots are complex, so we are going to write cout complex roots, and now we are going to again put it in the formula, that is minus b okay divided by 2a and here basically these roots are complex roots. Okay, so that means they are going to have iota, that is the imaginary number. So for that imaginary we are going to add the I, that is for the iota. Okay, and here we are going to write plus I, that is for iota. All right, and here we are going to give the value of the determinant. All right, that is sqrt underscore d. Similarly, this one is for the first root. Now we have to do the same for the second root. Okay, so let's put another cout, and here we are going to write minus double b by 2 into a, and the second root is going to be minus of iota. All right, that is minus iota, and here again the sqrt value, sqrt d, and we are going to terminate the statement. Yeah, so this is our logic. Now we are going to write the main function. All right, so in the main function we are going to take the input from the user. So we are going to write cout, enter the values of a, b and c. Okay, and we are going to input c in, that is a, b, a, b and c. All right, so now we are going to pass the values of a, b and c in this calc function. All right, so here we are going to write calc a comma b comma c. All right, so now our function is going to run. So this is all for this program. Let's run it and see if we are getting the desired output. So first of all, let's compile the program. Okay, there are errors. Okay, int c, I forgot the space. Yeah, so let's just compile again. Okay, we forgot the semicolon here. Yeah. Okay, there are too many errors. Let's just see. What is this error expected? This, we forgot semicolon somewhere else, I guess. Okay, everything seems fine. Yeah, why is this error there? Okay, it is saying that we missed a semicolon somewhere, but I am not able to see where we have missed it. Okay, so I got the error. Basically, in the third condition, when we are using if else, okay, when there is a condition, we use else if, then the condition. So here, when there is a last else case, then we do not use any condition, okay, and we have just declared the condition. So either we can do it as else if, or we can just remove this. That is for else this thing, okay. And after that, there is one more change in the main code as well. That is, we need to define a, b and c as well, because in the function, when we have defined these arguments, they are not in the same scope, okay. They were not defined globally, so we have to define a, b and c again. So these were the amendments in the program. So let us compile the program and see if it is working properly or not. So it has compiled properly, that is 0 error, 0 warnings, and let's just run the program. So here it is asking to write the values of a, b and c. So let us write the value of a, b and c as 4, 2 and 1. Let's see. So it is giving the answer complex root, that is minus 0.25 plus iota, alright, and minus 0.25 minus iota into 3.4641 into, and that's all. That is it is in the form of minus a plus minus iota b. In that form we are getting the complex values, okay. Let's just try for another equation. Let's see if we get the same values in any chance. Okay, first of all, let's put a as 0, all right, and see, it is saying invalid because it becomes linear equation, okay. So let's try for one more case to see if we get any other kind of roots. Okay, again complex root. Anyway, you can try for a number of cases when you have an equation for real roots and same roots, or real roots and different roots, you will get that answer. So this is how you make a program to calculate the roots of any quadratic equation. So this is all for this video. See you guys in the next video.